Hi, my name is Adrian. I am with AWS, and today we will discuss how AWS and Sequitur Labs combine services to significantly reduce the time to market for highly secure and resilient connected products. Critical infrastructure operators, manufacturers, energy and utility companies are facing an unprecedented volume of security threats. For these reasons, more and more requirements are being released to strengthen the security of connected edge devices. In industrial IoT, for example, the OPC-UA Field Level Communications Initiative requires zero trust security for device-to-device, device-to-controller, and device-to-cloud communications. Zero Trust Security Framework advocates trusting no one at any time, which translates into tight requirements for confidentiality, integrity, and access control. These concepts require the use of asymmetric cryptography, the use of cryptographic certificates for identity management and authentication, and frequent rotation of such certificates. This in turn requires the device to be able to handle keys and certificates and perform crypto operations in a very secure way. But before getting here, how do we know that the device is even running its intended firmware? How do we make sure that at any point in its life cycle, the device did not become a Trojan horse for the manufacturing plant? Or can we build devices that can monitor their security posture, detect issues, and fix them without human intervention? Trust must be set from the ground up and applied in layers, but we must start with the device processor. We need to make sure the processor has the necessary means to establish from start a trusted security framework to fulfill all security requirements for its intended normal operation, including firmware updates and connectivity to cloud. While many processors today provide the needed security features, the procedures for setting them up, manufacturing at scale with such capabilities turned on, and the software that makes it all usable require specialized skills and a lot of experience with a diverse set of silicon offerings. I'm happy to introduce you today Phil Altfield, the founder of Sequitur Labs, a company that dedicated years of work into abstracting this complexity with the goal to make it available to all customers of any size. AWS is working with Sequitur Labs to bring to our common customers a production-ready solution that spans across multiple processors and that makes it easy to develop highly secure and resilient edge devices for industrial and enterprise IoT. We'll also demonstrate how layered security protects the connected edge, build resiliency, and how AWS IoT complements it with cloud security monitoring.
Thanks, Adrian. I'm Phil Atfield from Sequitur Labs. Sequitur Labs delivers chip-to-cloud security for smart devices. Our award-winning products are used in IoT applications like industrial automation, smart home, and computer vision. Our portfolio includes the EMSPARKSecurity suite for device-level security and Empower, a cloud-based application for lifecycle management. Our silicon partners include Microchip, NXP, NVIDIA, and STMicroelectronics, and we're proud to be an AWS partner. Our solution achieves trust by design. IoT solutions vendors are looking to build trustworthy devices. Nearly all devices connect to some backend or cloud service, so the problem is how to ensure chip-to-cloud trust. This means authenticated boot code, application, secure failover and recovery, protected keys and certificates, IP protection, secure manufacturing, secure update, and secure lifecycle management. We recognize that the problem requires specialized skills and has a steep learning curve. OEMs also need to deal with a fragmented landscape of silicon and software options, all while holding their tight product schedules. To achieve chip-to-cloud trust, the industry needs a unified solution that is easy to deploy, works across various silicon platforms, and can scale to handle millions of devices. Our solution is the Sequitur Labs security platform. Our EMSPARKSecurity suite, which includes firmware, tools, and APIs for device-level security, significantly reduces the effort and risk required to implement on-chip security features. Our Empower cloud-based platform delivers a complete suite of services for managing device throughout its life, including secure updates and threat detection. Today's demo will show how Sequitur's solution is completely integrated with AWS in order to deliver chip-to-cloud security for an industrial automation solution. An industrial I/O supports a variety of industrial devices, interfaces with an industrial gateway or PLC using the EMSPARKSecurity suite for device-level protection and Empower for device lifecycle management. Empower supports AWS IoT Core, Device Defender, S3, and Lambda services to deliver our chip-to-cloud solution. The benefits are a complete set of security functions that are best in class in the industry, extensible across silicon platforms, and compliance to recommendations from OPC UA specifications. Key features include secure boot and updates, mutual authentication, software provisioning with anti-cloning protection, AI model and machine learning code protection, and advanced cryptography, key and certificate management. Let's get started. Today's example is an industrial control system. It features a microcontroller representing a field device using an LED to demonstrate command and control. The field device is connected to an MPU gateway that connects it to the AWS cloud. Zero Trust foundational security is implemented in the industrial MPU-based gateway using Sequitur's EMSPARKSecurity suite, and the device is managed by Sequitur's mPower Lifecycle Management Service, hosted on AWS and integrated with AWS Device Defender service for security monitoring. The demo is using the NXP IMX8 applications processor and the NXLPC 4377 microcontroller for the gateway and edge device. Industrial applications, and in particular, OPC UA field-level communication standards require a device to be provisioned, authenticated, and authorized with keys and certificates before being accepted to the operational network. Such capabilities require all devices to securely execute cryptographic operations in a separate domain, which is out of reach of the normal applications. Such capability is known as trusted execution. ARM-based processors use an architecture called Trust Zone for this implementation, but the building systems employing secure boot and domain separation using Trust Zone is complex, requires specialized expertise and experience to deal with a variety of silicon processor platforms. The EMSPARKSecurity suite solves this by supporting the industry's top silicon platforms from NVIDIA, NXP, STMicro, and Microchip, reducing the development cycle needed to port to new silicon. The EMSPARKSecurity suite sets up trusted execution in the NXP IMX8 applications processor using the security capabilities provided by the silicon. This means that EMSPARK provides the tools needed to set up the silicon and manufacturing while protecting the provisioning payload. The EMSPARKSecurity suite provides the secure operating system for the Trust Zone, called a Trusted Execution Environment, or T, a complete suite of trusted applications running on top of the T, along with an SDK making it easier for developers to implement zero trust applications. With this complete set of applications, EMSPARK provides secure boot, secure updates and failure recovery, key and certificate management, protection of intellectual property, including machine learning code and AI models, secure data storage, and seamless integration with AWS IoT. As we boot up the devices, we can see the EMSPARKSecurity suite creating the Trust Zone environment by partitioning memory, initializing Sequitur Corti operating system in the secure enclave, and securely verifying the authenticity of each component as it boots. This includes the Linux operating system. Private key and device certificates created in the device during the provisioning process and secure crypto using the Trust Zone and T provides the right security for TLS with mutual authentication with AWS IoT. For proper trust propagation, however, a secure tunnel is not sufficient. Security must be applied in layers. The extra step is to add integrity checking to every message going through the pipe or selectively to critical messages. This means that the application in the cloud must sign every message and must verify the signature of every message. Devices must do the same. Trusted execution is the critical component. This is the essence of zero trust architecture, and it's critical for securing the industrial applications to device-to-device and device-to-cloud. The gateway can now authenticate and accept devices that are attempting to join the network. Now, the device is accepted, and using mutually authenticated command and control, a message from a cloud application is sent to control the device. This command was not only verified by the gateway, it was done in the secure domain using credentials that can only be accessed by the gateway for verification. The gateway then prepares a signed command for the MCU in the secure domain. Now let's see what happens if bad data is injected into the system. We'll go ahead and press the malware button and push damaging data to the gateway. The malware is injected and the system is under attack. EMSPARK and Empower now detect and mitigate the threat. NXP IMX hardware is configured to detect these changes to unprotected regions such as the Linux kernel. The EMSPARK security suite is notified of the tamper event. Then, to address this, EMSPARK initiates a reboot in which the device is blocked and the system follows the secure boot process. Next, the EMSPARK security suite sends a secure, authenticated message to Empower, Sequitur's lifecycle management service. This critical data is shared with AWS Device Defender and can be used to update credentials on the gateway to make sure all devices are secure. In the event that the attacker has modified the non-volatile memory image, the failover to the secondary boot will become active and boot the system into a recovery image. When the device has completed its recovery and its status has returned to normal, an authenticated message is shared with AWS Device Defender and activity is logged. This mutually authenticated message, supported by Sequitur's Zero Trust security implementation, means that all messages, including critical notifications like this, can be trusted, creating a highly resilient system. Sequitur Labs and AWS are delivering a complete silicon-to-cloud security solution, allowing you to focus your time and energy on building great products for the IoT. It's easy to implement and manage and supports the best encryption, threat detection, and management techniques in the industry. For more information, check us out at sequiturlabs.com or on the AWS IoT Solutions repository. If you have any questions, you can contact us at info@sequiturlabs.com. Thanks for watching.
Thank you, Phil, for walking us through the technical details and the demo. IT-OT convergence sits at the core of Industry 4.0 concepts. It is a paradigm shift for the operational technology sector, and understandably, the in-house teams lack the required expertise to deal with large cyber attack surface that comes with it. AWS and Sequitur Labs partner to bring to customers and the partner ecosystem a solution that uses the cutting-edge silicon hardware features, but abstracted into an edge security platform providing a uniform development framework. We're aiming to offset the need for deep expertise in embedded security. To learn more and engage with us, please visit AWS and Sequitur Labs links included with this presentation. Thank you for listening and have a great day.